7?
No.
Or just the 2? Just the 8 and 7, right? So, first thing I'm going to write down is that x is equal to 0 point. You want to move your from 6, please, to the side so I don't trip on there. We have 0.287, and then what would I put down? 8787, right? So that shows me that the 87 is repeating. Next, I'm going to multiply, because two numbers repeat, we are going to multiply by 10 or 100 or 1,000.
No.
Two repeat, 100. Two repeat, 100. You didn't have 10 done, you're doing 10 with us, right? Okay, if you didn't have 10, oh, and see, if you don't have any work, I can't give you credit. So if you have that answer that you have there, that's not going to get you any credit, okay? So make sure you write this down with us. So we are now going to put 100x equals, we are moving it over 2 places, multiplying by 100. So I now have 28.78787. Everyone in agreement? Okay. What am I doing? I am taking and I'm subtracting these. So I need to put this x right below here. So 100x minus 1x equals 0.287. And this is nice because now I see, if I would have multiplied by 1,000, they did not line up. Okay, if you multiply by 1,000, there was no lining up of those decimal points, which causes us problems. Okay, so 100 minus 1 gives us 99x. These 8 sevens back here, they're all until 0.7 minus 0.2 gives me 0.5, and I get 28.5. To finish the problem, I'm going to divide by my coefficient of x. It was 99 times x. You guys solved equations last year. We write this as 99. But I cannot have a decimal in my answer. So even though I'd like to put 28.5 over 99, my last step is that I have to multiply both the numerator and denominator by 10 so that I do not have a decimal, and I get 285 divided by 990. Now, in years past, I would have been on your case to simplify this. And the easiest way to simplify this is you would have first divided both sides by, or numerator and denominator by 5, right? So if I divide both numerator and denominator by 5, you could have done that. But I'm going to be okay that you leave it like this. You will not have a calculator on this quiz. I hope you feel better. So 285 divided by 990. Did anyone simplify it? Because I mean, if you don't have a calculator on this quiz, I'm going to be okay that you leave it here. So to do your check on your homework as you do these, you would take on your calculator 285 and you divide it by 990. And hopefully you got 0.0287878. Okay? Questions? All right. So today, because there was quite a few people that didn't do page 3, I'm going to be passing around the scissors in a little bit. And what you're going to do is you're going to cut out in your homework a little later, we're going to cut out page 6. Okay, so 5's on one side and 6 is on the other. And the reason I want page 6 is I want to see at the bottom of page 6, number 21 to 24, that you did the work for those, right? So I'm going to hand you a scissors and we're going to cut out page 6. And the other page that we are going to cut out is this page 9 with 10, okay? So I'm just going to put page 10. So what you'll do is I'll hand you the scissors in a little bit, and you will simply, and the reason I don't want you to rip it out is because if you cut it, if you rip it at the base, then like the page behind it, like the answer key part falls out. Whereas if you just go down here and you cut this out just like right here, and it cuts in. What if you cut off a little of your work? That's okay if I see most of it, right? Okay? So a little later in class, I'm going to hand out those scissors for you to do that. Right now, we are going to do some notes. Okay? So last week, so set your workbook aside and go to A6 in your notes. Did everyone have a good long weekend?
Yeah.
That's not good.
Oh, were you?
So, last week we talked about all these types of numbers. Remember you guys sorted your irrational like we have up here on the board? So a rational number, if we were reading that description, a rational number. Erin, you want to read it for us? Right under vocabulary on the top of that page. In your notes. A rational number. Right below the word vocabulary.
Is a number that can be written as a fraction. It includes whole numbers, integers, fractions, terminating decimals, and repeating decimals. This includes squares, cubed roots that are perfect.
Okay, so clues are squares and cubes that are perfect ones, right? It can have integers, whole numbers, anything written as a fraction, decimals that repeat and end. If we were reading irrational, Sophia.
An irrational number is a number that cannot be written as a fraction. This includes non-terminating and non-repeating decimals. This category includes square and cube roots that are not terminating.
So our non-perfect square and cube roots. Okay. So when we are taking a look at these, I am going to be asking you to classify whole numbers. That is like our 0, 1, 2, 3, 4. So in this category, what I would like you to write down under whole numbers, if we are looking, I want you to put 0, 1, 2, ... That means going up, right, to 1,000,000, whatever you want. 1,742,372, right? Keeps going. In the whole numbers, will you ever have a fraction? No. But what if you had 6 divided by 3? 2. That's a whole number, right? So someone said, yeah, but that's a fraction. Well, I know, but it can be simplified to a whole number, right? If we are talking about our integers, they include all of these numbers plus -1, -2, -3, ... Those are my integers. So every integer, every whole number is an integer, right? Because integers include 1, they include all of these. Does that make sense when you look at this? It includes these numbers and it includes all of these. So it's 0, 1, 2, 3, -1, -2, -3, +4, -4, +5, -5. And then you get to rational. And this is where you're going to have the fraction part. So if it gives 3/4, that's going to be rational, right? It can't be an integer, it can't be a whole number. If it is 0.57 repeating, it's going to be rational, right? Because it says up here, it's our terminating and repeating decimals. So it can be our fractions. It can be something like 3/4, which is written as 0.75, right? It is going to be 0.57 repeating, because we know how to change that to a fraction. So it's any number that can be written as a fraction. Okay? So this is just about perfect timing. I don't know that we'll see all of it, but just about.
With a maximum speed of 2,193 miles per hour, the SR-71 Blackbird is one of the fastest jet fighters on Earth. It could fly you from Washington, D.C. to Los Angeles in barely more than 1 hour. It's ordinarily more than a 5-hour flight on a conventional plane. For the Blackbird to fly effectively and safely at speeds 3 times that of sound, its design and construction are critically important. Numbers play important roles in the aircraft's design and dimensions. To fit equipment, measure arc lengths, or make many other calculations, engineers often use a number called pi. Pi is the ratio of the circumference of a circle to its diameter. This ratio is approximately 3.14, and it stays constant no matter the size of the circle. Pi is an example of an irrational number. That's because even though it's a ratio of one length, the circumference of a circle, to another, the circle's diameter, it cannot be expressed as a ratio or fraction of two integers. It has no exact decimal equivalent. If we were to try to write out all its decimal digits, we would be writing forever, and the sequence of digits would never get to a continuously repeating pattern. Irrational numbers are numbers that cannot be written as the ratio of two. Can be considered to have a place along a number line. The square root of 2 is another irrational number, near 1.41 on a number line. The combined set of all irrational and rational numbers is the set of real numbers. Real numbers include all integers, all fractions or decimal numbers in between them, and all irrational numbers as well. Interestingly, between any two rational numbers, you can always find an irrational number and another rational number. And between any two irrational numbers, the same is true. As you can see, these sets of numbers are never ending, not only going greater and lesser, but going in between them as well.
So, when we look at our numbers, right now, what you are asked to do is to classify yours. Circle the numbers below that are rational and underline the ones that are irrational. So, go through right now and do your circling, right? Circle rational. We are going to be underlining irrational. Keeping in mind where your different sets are up here. Once you've done your circling and underlining, give me a thumbs up. You're also going to check with your shoulders. Okay, so check with the people sitting by you, in front or behind you, and see if you agree with what you have circled and underlined. Do you agree with, as you're looking at mine up here, that these are all rational? Rational means it can repeat or it can end. It would also be an integer. Could be a whole number, right? Why didn't I circle this one? 1, 2, 1, 1, 2, 1, 1, 1, 2. There is a pattern, but it does not repeat, right? This is not rational. This is irrational. So my underlines agree. If I wanted to be more specific, the most specific one is called our whole numbers. So if I was talking about whole numbers, I'm going to put a W by my whole numbers. I have this one, right? Do I have any other whole numbers?
Yeah.
What? Square root of 9. I'm getting more specific and I'm talking about my integers. Where are my integers? This one's negative. Is that an integer? No fractions as integers, right? Negative 12. Anything else? Oh, this is a whole number, right? 0 should have been whole number, W, right? And then, as we're looking at the rest of those, okay? So, it says various types of numbers are listed below. Label it with rational, irrational, both, or neither. Okay, so turn to the top of the next page in your notes. Please do this right now. So, you're going to put whole numbers. That should be rational, right? So you're going to go R for rational, I for irrational, B for both, neither. Question. Do this first and then yes. All of these, every single one up here is a real number. Fractions. If I was looking at what you put down for fractions, Stephen, what'd you have?
Fraction.
Yep, what'd you have? Rational, irrational, both, neither.
Rational.
Rational. Kyle, what'd you have for square root of a perfect square?
Rational.
Should be rational. Jeremy, what do you have for cube roots that are perfect? Rational. And Chase, if I go on to terminating decimal. Terminating. Can it be both rational and irrational? Should be rational, right? So our terminating is like 0.25, right? 0.4. Those are going to be rational. Repeating. What do you have, Jack? Irrational. Non-repeating. Non-terminating. Never ends, never repeats. What do we have for that one, Alex? Irrational. Well, can it both be the non-repeating and non-terminating irrational and repeating? Didn't you guys just write in your homework last night 0.75 repeating? Didn't you just write that as a fraction? Wasn't that the assignment, to write repeating decimals as a fraction? Didn't we just say, oh, if it's 0.6 repeating, that's really 6/9 or 2/3, right? If it was 0.5 repeating, that is 5/9. We did that work of subtracting. So can this one be irrational? Repeating decimals, those are always going to be rational, right? Repeat is rational. Why? You can write as a fraction. Anything you can write as a fraction is rational, okay? All right. So, Ella, square root's a non-perfect. Irrational. And if we are continuing with that one, Haley, what do you have for the next one? Cube roots that are not perfect. Irrational. Can there ever be any that are both? I mean, it's either one or the other, right? It has to be one category or the other. And neither, that is only when you get into your Algebra 2 and we talk about the imaginary ones. So we shouldn't have that. So what I want you to do is put it in the right spot, okay? And then as soon as you finish this, if you turn to that next page, you see where it asks you to write on the top of the next page? But right now, do this first. Do this first. So, like square root 3. Square root 3, if I'm looking at that, should be in which category? Square root 3 should be in irrational, right? 2/7 should be rational. Okay? So write them in where you think they belong, right? And then I'm going to have you check up here, but do yours first. Someone said, can I just draw arrows? Sure. Do you agree with 4 whole numbers? Square root 16, 5, square root 100, and square root 1. All whole numbers, okay? Not written as a fraction or decimal. Integer, -3. Getting more general, every single one of these in all of these categories down here, whole numbers and integers, is rational, okay? and then my irrational. Those are my non-perfects. So square root 3, square root 12, square root 99, square root 29. Remember when we did this one, we had pi. We had negative pi plus 1, negative pi minus 1, 2 pi. When we did that sorting activity. So keeping in mind those ones. If I would have given you something like negative pi, right, plus pi, negative pi plus pi, that is going to be a whole number, right? If I have negative pi plus pi, that equals 0, and 0 is a whole number, right? So when we're looking at those, or you're giving examples of different ones. All right, so the top of that next page, you are asked to write, and so I'd like you to do that. See how you do. Write as many of those right now, right? Filling in. And I'll give you a couple minutes to do that. And we'll take a look. So if I'm looking at my squares, as I'm looking at those, 1, 4, 9, 16, 20. Hopefully you guys did okay getting down to 100. Now, if you got those next two, this is where most of you, I didn't hand back that quiz because most of you got 4 out of 4, and I haven't entered that grade for last week. But when I start this one, I'm taking that first one, and taking it times 1 more, that still gives me 1. I'm taking 4 times another 2, that gives me 8, right? 27. If you didn't have 8, I saw some people with some other numbers. Make sure you get the right number there, right? I'm taking 16 times 4, that gives me 64. I'm taking 25 times 5, that gives me the 125. Now, I agree, these last ones from here on that I have covered, these are the tougher ones. And for me, that's what I would say you should practice, either on Quizlet or making flashcards or just writing those, okay? Because that is where you are probably, most of you are probably struggling the most. 169, 196, right? Those are just kind of reverses of each other. 225, 256, 289. Did anyone see a pattern by what is added each time? Add 5, add what? 9 plus 7, okay. So add another 9. So if I get to here, okay, 121 to 144, what are you adding? 23, right? And what do I add to get to the next one? 25. So what if you get to 169, 196? Could you then start looking and go, oh, I'm going to add on 27, and then I should add what next? 29. So, I mean, I know we want you to memorize this, but we also want you to think about patterns. So could you think of that and keep going and go, oh, now I'm going to add 31 and 33, right? Whatever will help you to be able to do this quickly. Because this is what the first, how many points of the quiz look like on Friday. I just give you with those blanks right behind them, just like you just saw. Okay? So, if you do get stuck and you get to here, and then you can't remember, you can go, oh yeah, this was 23, 25, 27, and you should be able to do the rest of them, right? Okay? I'm not sure if you'll remember the patterns here, but sometimes as you look at the numbers, multiplying that 49, remembering that this is your 49 times 7. And some of you will go 49 times 7 and you'll multiply it out. Right? I mean, if you need to do that, you do that, right? All right. So, here is your assignment, if you would please turn. And I need you to add on the bottom these two. And I said we are handing in page 6 and page 10, right? So you are cutting out and turning into me for points. Okay? Now, I'm going to pass the scissors around in a few minutes, but add these two at the bottom, right below number 18. Kind of halfway down on the page, right? So turn to the A6. And you see where number 18 is? Okay? About halfway down, so you have room to write a comparison. Tell me how they're similar and different. Right. Approximate the square root to the nearest 10. Use 2 number lines, show all work. There are 3 like this on your quiz Friday. There are 3 like these on your quiz. So this is a good time to practice this. Okay? This is like the page 10 or page 6 that you're handing in, right? On the bottom of page 6 that you're going to cut out for me. The top ones on this worksheet, what are you asked to do? Do it right over here, right below the 18. Okay? Now, there were some of you, when you drew your number lines, you did not put the same 2 points above and below each other, right? You didn't line these up. You need to line these up. So we're finding the square root of 60 and the square root of 130. You're thinking, oh, the square root of 60 is somewhere in between here. What 2 perfect squares that you just looked at is 60 between? 64 and 49. Between 64 and 49. So I can go square root of 64, right? And square root of 49. 7, 8. I know my answer is 7 point something, right? Next step, you have to find the halfway point. You're going to put that number that's halfway between 49 and 84. And then you're going to go, oh, 60, it's probably closer to 64, don't you think? I mean, if we were going to estimate it, we might just estimate and go, oh, without showing my work, I might show 7.8 or 7.7. You want to make sure I can see that you estimated it in that region, okay? So on the quiz, this is worth 3 points. This is worth a point. You telling me the answer, right? I need to see this work. And I'll have some of you just put 60 right here. It's not 60 right there, okay? So find that middle. Okay? Questions on anything?